There's a driver for doing digital transformation, and the driver that I find is sort of your state of your industry in 2019. There's three different things that I found that I thought were really relevant. One is the amount of growth or lack of growth, depending on where you were geographically. The second is how your consumers are changing. They have more of an awareness today of environmental, I call it their environmental awakening, on needing recycled products or wanting to know what the footprint is, or concerned about packaging, how they're buying products. We've gone from mom and pop shops to buying products to now doing almost everything online. And so that's driving different pressures on your margins and prices. It's changing. One of the conversations we got in the other room was about traceability and serialization. A lot of our new projects are not due to necessarily a need for an ROI, but a need for being able to trace things due to governmental regulations. And finally, the last part is really some of the adaptation that the production people are doing, in that they have to make faster products to market and change up what they're making. And so they need more modular machinery so they can change around the skid combinations or change what they're making in a quick manner. All these things are driving, you've seen this graph before, but all these things are driving that need for a step change. And that's what digital transformation really is. I think, we have an example here of all of us that have been affected by digital transformation one way or another. If you remember, the old phone systems used to be on your desk and you picked it up, and then I went to a brick, and then I went to this device. Now this device is our link to computer, our phone system, our photography tool. I do my webinars on it. So we've all been through digital transformation, but what I found from your industry report, I put it in a different format because it was easier for me to see. This is from IHS Markit, and it was a study called Industrial IoT Readiness, and it is on the PMI website. That 38% of y'all have been through a proof of concept, either proof of concept or enterprise-wide application. 25% of you have seen some value from that, or ROI, or return on investment. 10% none, and then 27% haven't really gotten started in anything. And that's the concern for me. If you're going to address the state of your industry, if you're going to address those factors, you need to be doing something differently. Why data management? Well, if you look at the same reports and go a little bit further in them, of the top 4 challenges to implementing digital transformation, 3 of those challenges have something to do with data management and data integration. Either getting information out of systems, sharing the information, or being able to receive data and analysis on that information. So you have lots of data, what do you do with it? What's the importance of it? And also, when you're looking for what the 6 pillars of readiness for doing digital transformation that IHS talks to you about, all of those touch on data management in some form or fashion. So recently I was in Taos, New Mexico, and there's this great geographic feature called the Gorge Bridge. And I thought it was a good representation of what we're trying to do with information. If you think about one side of the bridge being on-prem production facilities, you have material and data that's very time sensitive. Those factors are very important. On the other side, if you think about your business systems or the off-prem systems, those systems tend to have cybersecurity issues, proprietary data that you don't want to share with other people. And so to be able to do something, you have to really communicate across. And a great example of that, one of the things we do in our business is reliability consulting. So if you go back in the old days of reliability, you remember maintenance was when it failed, fixed it. That was pretty much how we did maintenance. And then we came up with preventative maintenance. Preventative maintenance meant that, on a regular basis, maybe every 3 weeks, I came to a piece of equipment and I put my thing up to listen to see if I heard a bad sound, or I touched it to see if it was vibrating. But that was very people intensive. It took a lot of resources to be able to go around. It took a lot of sort of inherent knowledge on how do things fail and what are they doing when they fail. We got a little bit smarter. We started putting transmitters on things. So we started measuring vibration of transmitters or temperature rising or pressure rising. And we could use those as a predictor that something was going to fail before it actually failed. Again, that's expensive too, and you only wanted to do it to the devices that were pretty critical in the process. Today, crossing that information, if you can pass information back and forth between business systems, you can put analytics on. I think you all went out there and saw KNet. We use that quite often in reliability to help do what we call prescriptive operations or prescriptive reliability, which means we back up even further on the curve and find information far ahead of time when something's about to fail. So for one application, we had a client that was very interested in a certain pump. It was very critical to the process. It was failing quite often, and they needed to be able to predict ahead of time when that pump was going to fail. And so they put different characteristics around that pump, and we're measuring it in the analytics world. Well, their operator was sitting in with his little screen running his process, and he gets the indication from the KNet system that the pump is flowing. The feature's going to fail. You need to contact maintenance to go out there and fix something. The temperature's rising, and we believe that this valve is stuck. And he's like, the valve's not stuck. He's looking at his window of information that might be a month at most, and he doesn't see the temperature rising. But when the engineer came in and said, let's back up 3 months, let's back up 6 months, you could see the trend. And to the operator themselves, it looked flat. But the analytics was able to use all the different factors to figure out that there was clearly a stuck valve. And when they fixed the valve, the analytics flag cleared. And they found that there was, there wasn't actually a problem other than the valve was stuck. And so temperature was just slowly creeping up, and eventually it would have been a problem that caused them down production. So having that ability to communicate information across is really important. In a typical production site, if you have a medium facility, you have lots of information. You can see the calculation here. You have 1.57 trillion bits of data if you just take it at once a second for one tag for each of the tags in the system. But the question becomes, is it really enough data? And it is the right kind of data. And is it correct? So having worked in a plant before, I know that sometimes when you're going back and looking at data, you'll find that there's blips in it for, it'll seem like it's running along here and all of a sudden there's a value that's out of range from normality. And if you're doing calculations off your data, how are you thinking about correcting for that? Are you dropping that data? Do you have systems in place to do that? So data management is more than just collecting the data. It's fixing it, making sure it's correct, and making sure disparate systems coming together, the data can work together. Data comes from a lot of different sources, and integrating them can be very difficult. And what we suggest you do with data management is really think about what you want to do with that data. Where's the data coming from? Is it coming from a lab system? Is it coming from production? Is it coming from transmitters? And what do you want to do with the data? Do you want the data to set an alarm on the screen like we had with the operator? Do you want the data to close the loop like Peter Zornio talked about this morning? He said, in process control, we close the loop easily. But do we also now want to close the loop so that if there's a problem with the system, that a work order or change order is automatically sent out so that somebody will arrive? I don't know if you've ever seen the commercial. I think it's the greatest commercial in the world of the elevator repairman that shows up. Have you ever seen that one? And he comes to the front desk and he goes, there's a problem with your elevator. And she's like, no, there's not. And I think that's a perfect example of analytics and how it can work and how you can close that loop. So, but I think one of the most important things I want to say in this is you not only when you do a proof of concept and you roll it out, you've got to consider the training for the users, right? We've all seen an example recently in the elections. In the Iowa caucus, Software app, new app. What was the biggest problem? Not only that the software had problems, but also that the people in the precinct didn't even know how to download the app to their phone. And they didn't know how to use the app. So if you're thinking about data management, it's so tightly connected with doing new applications and making sure your people are trained so they know how to use those applications ahead of time before it becomes an emergency. Real quick, these are some of just a summary of the challenges that we talked about. Things that are a little bit different on this slide are the last two here, the data consuming applications. Ed talked about, sometimes when we're pulling information together, we only do it for our silo, right? We're doing this application, and so all I'm looking at are these pieces. And what we would ask is that you sort of take a step back and try to think on a bigger level, what do you want to do with your information? What that'll help you do is that'll help you save time so that you're not reworking it and reworking it and reworking it. And it'll save you a lot of time up front if you think about what you want to do with your data. Where's the data coming from? What might you want to do in the future with that information? And finally, I talked to you about that operator that was sitting there running the plant. We really have to think about the correlations between the data. It's called the butterfly effect. It's the theory of chaos. If a butterfly flaps its wings here in Texas, is it going to affect something in Canada? Right? Dapo's in Canada, so that's why people know. But it's really if you limit access to information to people, then you might also limit their access to be able to make those correlations. And the real reason for doing digital transformation, for bringing all this data together, is we are trying to make either the operators or the engineers or whoever's dealing with the information and trying to make sense of it, we're trying to bring them up to that super user level, right? We have operators that just have a sense and a feel for how things work and how it fits together. And we're trying to sort of level that field for the digital natives and the new people coming in so that they can have some decision support tools that make them also experts and raises the production level and raises what, operating at the front. So in our solutions, we talk about doing three things. First of all, developing some kind of centralized platform. It could be on-prem or it could be off-prem. And there's two pieces to that. The first piece is gathering all the data from the different bits that you're going to need. And then the second piece is really contextualizing that data either from time stamping, tag stamping, just so the information can work together. And filling in those holes when there's those dips in the data so that you know what to do with it in your calculations. And we have a process. And I think this is what you guys are going to go through this afternoon, is really talking about what your roadmap is and how you move forward. So what we suggest from a data management standpoint is, your production, your machines. We have a better sense of information and integration. Not everybody can afford to have separate capabilities in those areas too. So we would go in and assess where you are today from a digital maturity standpoint. What kind of systems do you have in place? How are you moving forward? Or what kind of systems don't you have in place? And where do you want that information exchange to take place? Coming together with a workshop, Ed talked about 3 different levels. I'm talking about the consulting level workshop. We only work in the operating domain, the OT area, in the sense that we are not trying to do your finance systems and we're not trying to do your HR systems. Our expertise is really in operational technology and IT around the operations. We would put together a roadmap with you. First off, we recommend proof of concepts because that's a quick way to go out and check and see if it works. If it then works, then you can expand out enterprise level. And then as time goes on, once you've built a roadmap, you're going to have to go back and reassess that roadmap and decide whether the technologies that are coming online, things are changing so quickly today, does it make sense for you to take advantage of those, or does it make sense for you to continue on the roadmap that you've created? That will bring you digital transformation. We have a specific model that we use. This is our own model. It's very similar to some others. we put in 2 domains, the impact domains. Those are things that are actually going to affect your production, your system. The other 2 are your enabling domains, the information. You can't do one without the other, and the people. So these are, if you did a comprehensive assessment, we would assess at each of these levels. Most people typically pick one or another. They're working in production or they're working in reliability. And it's not necessarily a straight line. Each one intersperses with the other. If you change something in production or change something in reliability, it's going to affect your production. I'm bringing up the tool that we use that our data management team has brought with us. It's called Magnonics. It can help with on-prem systems, connecting transmitters information up to the on-prem system, or it can take it from on-prem up to the cloud. It's a data tunneling system and helps with that data federation level.
Yeah, no, great. I mean, thanks for touching on that. Magnonics, I think like Shirley mentioned just now, is like our IoT real-time and historical data workflow engine that we created. We kind of look at it as an integration accelerator, right? So it really helps with data integration and to accelerate like visualization initiatives. So some of the examples and use cases really for Magnonics is really centered around as you start to look at projects where you're looking at liberating your data, moving some data from on-prem to either an advanced or a L4 platform like the cloud, where you want to do advanced analytics, or you want to drive some further insight on your data that you can't do with the systems that are on-prem. And you're trying to commingle different types of OT data. So you might have data from lab-related type data. You have operator logs. You got could even be CMMS data from your maintenance system that you want to bring it all into one central repository where you can commingle the data together with context and properly relate them. So if you kind of look at the screen, if you look at the screen Shirley has up here, where on the far right, where we're looking at a case of a client, a chemical company that we worked with, that their focus was really around product quality, right? So they were looking at some of their catalyst batches that they're currently making, and I guess the real opportunity here was trying to figure out how do you predict the performance of each catalyst batch to identify process variables that could kind of cause what they call sticky red, right? So essentially a bad batch. And so there is a transition period when these catalyst batches are changed that need to be identified and then properly removed. So essentially taking a proactive approach to it. So we leverage Magnonics as an accelerator to actually bring data from their real-time system, because they were running an Aspen Tech-based data historian for all their real-time operational data. And then they had a homegrown Oracle database system for their operator logs, and then for their lab management system, they were actually using SAP. And we were able to build Magnonics nodes that integrated with each of the disparate systems and centralize that data into a Microsoft Azure platform, because they wanted to get the data into the cloud, where they could use Azure Stream Analytics and Databricks to perform advanced analytics with the machine learning capability to drive further insight into how do you improve that whole quality process. And some of the outcomes from that was basically they were able to kind of reduce their production excursions that they were experiencing and understand interactions properly between the catalyst and actually the feedstock to be able to manage the feed to the batch production and ultimately reduce the sticky resins that we're experiencing. So
one of the things.
Go ahead.
Yeah, one of the things that came up in the other room was you'll recognize we work with a lot of disparate systems. So from a consulting standpoint, from a data management standpoint, we have to be somewhat vendor agnostic.
Right.
Not everything is going to be on top of a membership system. And so we're able to take that capability and pull in, whether it's from Emerson or from the other systems, to be able to work together, because most of our clients are working with brownfield. And a lot of times they're acquisitions that are built from a lot of different companies. And so, we're not just working and connecting Emerson to Emerson here at this level.
Thanks, Shirley. I appreciate expanding on that, because the focus of the data management team really, as we work mostly in brownfield projects and initiatives, is really around being very vendor neutral. So as part of the assessment phase that Shirley mentioned earlier, that's where we identify the different systems and data sources that you have, and we're able to leverage those same tool sets and identify anywhere that there are gaps. If there is a gap in terms of them meeting the objective, then we can start to look at, what other commercial off-the-shelf type solutions are available that best, meets or fills those gaps.